So let's go over the extra practice questions from this section. Before we do that, let's review what are parallel and perpendicular lines. Parallel lines are lines that are in the same plane that do not intersect. So in our diagram below, we have the blue and the green line, and notice that they do not intersect. If we examine their slopes, starting with the blue line, so let's say we take this point here, I can count 1, 2, 3 up, and 1, 2, 3, 4 to the right. So this blue line has a slope, m, equal to 3 over 4, rise over run. If they're parallel, we're going to notice that they have the same slope. So let's start from this point here, 1, 2, 3. So there's 3 up, and 1, 2, 3, 4. 4 to the right. And again, this line here, we'll call it line number 2, has a slope of 3 over 4. So we see that parallel lines have the same slope. So in our example here, the slope of line 1 is equal to the slope of line 2, or m1 equals m2. For perpendicular lines, again, they are lines that are in the same plane and intersect at a 90-degree angle. If we examine the slopes for perpendicular lines, we're going to see something different. So let's start with the blue line. So starting here at 0 and 5, we can count down 1, 2, and go over 1 to hit the next point. So this is down 2, so that's negative 2, and to the right 1. So the slope of our blue line, m1, is equal to negative 2 over 1. Now if we look at the green line, starting here at 0, negative 5, we can go up 1 and to the right 2 to hit our next point. So that's 1 and 2. And the slope for our green line, m2, is equal to 1 over 2. And notice if we look at these two slopes, negative 2 over 1 is the negative reciprocal of 1 over 2. We just flip the fraction and change the negative to a positive, or if it was positive, change the positive to a negative. So perpendicular lines have slopes that are negative reciprocals of each other. So if you like, we can say that m1 is equal to 1 over m2 and throw a negative in front. So now let's go through the questions. Determine the equation of a line given the line is parallel to y equals negative 3x plus 1. So remember that negative 3x plus 1 has a y-intercept of 1, and a slope, if we look at the slope here, we'll call it m1, is negative 3 over 1. Remember that negative 3 is the same thing as negative 3 over 1, so it's down 3 and to the right 1. And we can plot a couple points. So this is negative 3x plus 1. But we want to find the equation of a line that's parallel to this line and has the same y-intercept as y equals x plus 7. Well, for y equals x plus 7, there is our y-intercept. So our new line has to pass through the point 0, 7, so right here, and it has to have the same slope, since it's parallel, to the first line, negative 3x plus 1. So that means we're going to have to go down 3 and to the right 1, down 3 and to the right 1. So here would be the equation of the line that we're looking for. So we're going to take two bits of information. We're going to take the slope from line 1 here, the y-intercept from this line here, combine them to make the equation of our new line. The equation of our line is y equals mx plus b. We know that the slope of line 1 is the same as the slope of line 2, so y equals negative 3x, and it has the same y-intercept as this line here, so this would be plus 7. So that is the equation of this red line here. So a line that's parallel to negative 3x plus 1 and has the same y-intercept as x plus 7. Next one. This time the line is perpendicular to negative 3x plus 1, and it has a y-intercept of 0 and negative 4. So let's draw this line again. So it starts at 1. It has a slope of negative 3, so 1, 2, 3, and over 1. 1, 2, 3, and over 1. That's this here. This new one has a y-intercept at 0 and negative 4. But in this example, it's perpendicular. So our green line, we know our slope is negative 3 over 1. Since it's perpendicular, the slope of our new line. We'll call the slope of our new line M2. We know it's a negative reciprocal of negative 3 over 1, so I'm going to flip that fraction, which gives me 1 over 3. I'm going to change the negative to a positive. So this one should intersect at 90 degrees. So let's try it out. So starting at this y-intercept 0 and negative 4, we're going to go up 1 and to the right 1, 2, 3. And let's connect those points together. And notice this does cross at a 90-degree angle. So the equation of our line, y equals mx plus b. So the equation of our line then is y equals, so our perpendicular slope is 1/3 x, and then plus, and in this case b is our negative 4, so minus 4. That is the equation of this red line here. All right, this one's a little bit trickier. A line that's perpendicular to y equals 2. Y equals 2 means that all the y values equal 2. So if all y values are equal to 2, we get a horizontal line. So we want a line that's perpendicular to y equals 2, but passes through the point negative 1, negative 3. So let's go find negative 1, negative 3. That's right here. And it's perpendicular, so it has to go 90 degrees. So if it's 90 degrees to a horizontal line, we're going to end up with a vertical line. And notice for this vertical line, all the x values are the same. And we see that all the x values are equal to negative 1. So if that's the case, then the equation of this line is x equals negative 1. Okay, so we don't worry about slope and y-intercept here. We're talking about vertical and horizontal lines. And finally, the last one, a line that's now parallel to y equals 2. So remember, y equals 2 is a horizontal line with all the y values equal to 2. Passes through the point negative 1, negative 3, this new line. So negative 1, negative 3 is here. And this time it's parallel. Notice all the y values are now the same. So this is the equation y equals negative 3, because all the y values have a value of negative 3. So this is the answer we're looking for.